Hi, my name is Dan Low. In this video, I'm going to show you how to write a simple Python program to translate a string to notes that represent a song. So basically, we're going to convert this string that represent notes in a song and then convert that to waves that you can play it in your computer. For example, MP3 or other music file format. So what will you take away? Well, first let's listen what you can do after this video. So basically this music is generated by the program, and the program is very simple. Okay, okay. So you can learn the basic Python programming for regular expressions because we use regular expression to represent notes. And basic music production using VST. VST stands for Virtual Studio Technology. So the free software you need, first, the Anaconda 1.9.12 and the Jupyter Lab 0.35.4, and also Python 3.7.7 plus 3.7.3, and the Music Score 3.4.2. Waveforms 11.3, and this is to convert the notes into wave forms or wave files. And then I use the Ample Sound Guitar M Lite 2 to produce a guitar song, and I use a Scamp to produce the notes. So let's start with the note names and durations. So each note starts with a lowercase note name from A to G, followed by either a pound sign that represents sharp or B that represents flat, and followed by octaves. Uh, we use the command to represent a low one octave. If it's two commands, the two lower octaves, and use a tick to represent the one high octave. Okay, if two ticks, there's two high octaves, and followed by the duration number, like one represent the whole note, two represent the half note, four represent quarter note, and eight represent eighth note, and so forth. And the note name is start from A, B, C, D, E, F, G. Okay, and all lower cases. The anchor note we set it to C equal to the pitch 48, and that actually is C2, not the middle C, the one octave below middle C. And sharp and flat uses a hash or pound sign to represent sharp, that increase the pitch by 1. And B represent flats, that decrease the pitch by 1. And one octave high using a single quote. Okay, for example, C quote or tick represent 60. Okay, and one octave low using a comma. So for example, C command represent pitch 36. Duration is a number, like for example, the number of bits is equal to 4.0 divided by the number, like the number, let's say 4, like a quarter note. Okay, then 4 divided by 4 is 1, so that's 1 bit. Okay, in the software. So now let's represent a song using strings. So for example, C4D to E8 now will be converted to C is 48, and then velocity is 1.0, and the duration 4. The quarter note is 1 bit. Okay, and similarly D is 50, and 1.9, 2.0, and I think there's some typo here. And okay, and then the E is 52. Okay, and 1.0 0.5. And a song is a collection of string representations of notes. So for example, the canon in D major is represented by this string. Okay, so we actually will play this, we'll convert it to notes and play it later. And the data process flow is like this. First, with the Jupyter Lab, basically, you write your Python program there, and then that will convert the notes, into the music XML using Scamp. Then we feed the music XML file to music score, and music score will then produce the MIDI file. The MIDI file will then be imported to a waveform and with the ample sound guitar. Okay, so I'm going to show you the programming. So the program start with at the beginning we right here at the beginning we define the pitch using the dictionary array in Python. So we define pitch C is 48, D is 50, E 52, and so forth. The reason we define this dictionary array is because we want to reference to each pitch using the note name. Okay, so you can go ahead, run it. Then the next one is probably the most complicated part of the program. So basically, we're gonna define node to name to note uh, function. So this function will take the note string and then convert it to a table that can be played in the scamp to generate notes. Okay, so the input note we use this regular expression to represent it. So basically, the note has start with either A, B, C, D, E, F, G, lowercase later, and followed by either 0 or 1, either a hash or flat. Okay, and followed by 1 or 0 or more the comma that represent low octaves, and tick or tick represent the high octaves, and followed by a number. Okay, and this program basically this function try to parse the input, the one note. Okay, it's a string, and start with the default setting. So because eventually we will not generate pitch and duration, so we set a pitch to the pitch C, which is 48 in this case, and then the duration set it to 1.01 bit in this case. Okay, and then we're gonna go over each of the attribute of the note. Okay, so we start with to find out which note it is. So we use a regular expression search, uh, the first character A to G. Okay, and once we find it, okay, then we can actually get the pitch out of it from our the result, the search result from the regular expression. So if it's A, it's going to reprint the pitch of A back to the pitch. So pitch will reset to the correct pitch. Okay, and that is the base pitch. Okay, and notice that I have wiped out the no name because there's a case that's BB. BBs represent the B flat. So there's two B's there. Okay, there are two B's there. So we need to wipe out the one of them. Okay, otherwise it causes problem later on because the B's represent flat. Okay, now once we got a no name, the next thing we're gonna parse the either sharp or flat. So if it is sharp, we can increase the pitch by 1. If it's flat, we can decrease the pitch by 1. Okay. So again, we use a regular string search, to get the either hash or B. Okay. So once found, okay, if not found, we don't do anything. If found, then we're gonna increase the pitch or decrease the pitch accordingly. If in the if and else. And after that, we're gonna count how many high octaves or low octaves we have in the input string. So by counting the number of comments or number of ticks, then we'll be able to adjust whether it's C3, C4, or C0, C1. Okay. So we use a find all to find all the occurrence of the command or tick. Okay. So if the so once we get back the result gonna be a list of the found tokens that are command or tick. Okay, so if it's command, then it's lower octave, so the pitch will be decreased by 12 every octave, so 12. Remember that. And if it's a tick, then the pitch will be increased by 12. Finally, we're gonna parse the number, the duration. So the duration basically we search whether there are digits, actually not digit, number there. So it's backslash digit represent one digit, and plus means zero, plus means one or more digits. Okay, and we search that if we found, okay, then the duration will be 4 divided by the integer 0. Okay, not integer, the result of the number, and we'll convert it to integer and divide it, and that will be it. After that, we return the pitch and then the velocity. Velocity here, we don't do anything about velocity. We can do something in the future, and then the duration of the pitch. So that's the name to node function. So we can go ahead and run it, and then we can put in our this name to node. Okay, let's say name to node. Okay, C8 for example. So C8 it prints out 48. Okay, and then velocity is 1.0. The duration is zero point 0.5. Why? Because we put a eighth note here. Eighth note is a half bit. Okay, if you change it to C4, it can have represent 1 bit. Okay, okay. If you change it to D4, okay, got 50. If you say 1 octave high, okay, that will be 62. Okay, so that is the name to node function. So next we're gonna convert a given string to that represent a song of notes. Okay, to other notes by calling the previous name to note name to note function. Okay, so here again we say we parse this note. This represent one note with the attributes. Okay, so the regular expression is basically gonna find all the notes in the given string in this way. Okay, so once we get that all the notes parsed, we're gonna put all the notes well, the results in a list of notes. Okay, so we're gonna go over all the notes in the result. Okay, and then append it to the list of tuples basically. So return value is gonna be a list of tuples, and then inside we use a name to node to convert that. So we can convert that. Okay, so now let's say we have a song like a C sharp, and then 1 octave high, 4 D8 for example. So if you run it, you're gonna return a list of two tuples. The first tuple represents C sharp high octave, which is 61, 1.0, 1.0 because it's 4, and D is 50, C is 48, D is 50. Okay, so that is a 50 and 1.0, 0.5 because it is 8. Okay, so now we got the song to notes converted, and now we can start import the scamp, ready to generate notes. Okay, so import it, and then we're gonna create a session as usual and set a tempo to 120 and new a part called piano. Okay, and that's the normal initialization in scamp. So after that, we will set this. I pre coded the song. Okay, so this is the canon in D. Okay, so we're gonna play it. We're gonna generate all the notes using the song to notes function we created earlier, and after that we're gonna play each node one by one using the definition. Okay, so we can just run it. So this is canon in D major. Okay, so that is working very good. Okay, now next we're gonna generate the MIDI file, then to trigger the ample guitar VST. Okay, uh, mapping, chord mapping, I get it out from for you here. Okay, so if we get a C low octave, okay, to the D sharp uh, low octave, you'll get chord C major, A major, D minor, F minor. Okay, so from C to D sharp there are four keys there. So basically, if we send C command to the ample guitar, it cannot play the C major for us. Oh, that's what I mean. If it's if we send a D sharp command, okay, that note to the ample guitar, okay, you're gonna play F minor for us. What I'm going to do here is I'm going to generate a chord progression like a C G A minor E minor F C F G, like the song you hear at the beginning of this video, and this basically be transcribed to a C low octave. Remember, we're going to play the C chord. So C command will map to the C major, the C chord. Okay, and then the one is the duration, which is the whole note, 4 bits. Okay, in 4/4 time signature, and G command right here is gonna generate G major, and that's what we want, G major. So by doing this, this is a string, translate from the chord progression sequence here to the string. In order to trigger the ample guitar, you need to send two signals over. The first you send the strumming pattern. Okay, so I send this note. Okay, send this note. This is a strumming pattern. This is C sharp. Okay, over the ample guitar. If you look at this page, I think it's around page 55. Okay, so you can see that the strummer key switches. So from here, the blue ones that will control the chord right here. Okay, so if they use C chord, then you need to send the C1 right here. Okay, and then there's a yellow part. This yellow part, orangey. Okay, so yellow part right here. There's a yellow key right here, and that will allow you to select the patterns. So we need to send the two signals over. So the first signal I send over is a strumming pattern. So and here I use a technique, in the scamp. I set a blocking to false. Otherwise, you're gonna stop there. You will not create the simultaneous notes together. So if you want the notes to play together, you need to set the blocking equal to false. Okay, the default is true, so you need to play one note after another. Okay, and I set it 32 bits. Okay, because I cannot generate 32 bits here anyway. So then after that, I just simply convert the song to notes. Okay, using the song to notes to convert the chords right here. Okay, and then after that, you're gonna have the each notes return back, and I gonna play it. Okay, so I use a play asterisk note. The note here is a table, so you can say star a table that will pass the argument to the play note. Okay, and then I transcribe it, so you can just run it. So the song you hear may not make sense to you, but it makes sense to ample guitar. So now that those note sequences being converted to the music XML, so it's gonna pass to the music score, and then we got this score. I'm gonna export this to MIDI file. Okay, so I can set it to MIDI file to test. Okay, and then save it. Okay, and I have one there, so overwrite it. So I'm gonna over here. Okay, so it's a import. I say yes. Okay. So now I gotta import it there. Okay, so I can start playing it. Okay, start from the beginning. So it's A minor, E minor, F major, C major, F major, G major. Okay, so that's the video. If you like it, please subscribe it, thumb up, or give comments, share. Thank you. Have a good day. Bye.